In this example, we're going to discuss the exponential function dealing with radioactive elements and half-life. An unknown radioactive element decays into non-radioactive substances. In 240 days, the radioactivity of a sample decreases by 40%. What is the half-life of the element? And then, how long will it take for the sample of 100 to decay to 99 milligrams? Well, the first thing we have to recall is that the half-life is when the element decays to half of the original amount. So just taking the information that we know about radioactive elements, we know that this is first going to be of the exponential function a of t equals a sub 0 e to the kt, where a sub 0 is the initial amount and k is the rate. In this case, it'll be a decay rate, and where k will be negative. Okay, well, in order to answer the question, the first thing we need to determine is the k, right? The rate. So the first thing we're going to do is go ahead and use the fact that when t is equal to 240 days, that the amount is only 40% a decrease. Here is 100% of the element, and then here's 0%. If the sample decreases by 40%, that means it went from 100% and it decreased by 40%, which means that really the amount left in the element is 60%. So we have to make sure to understand what the given is giving us. It's not 40% of the amount. It means that the element decreased by 40%, which means that there's 60% left. So A would be 60% of the initial. So putting this into A of t equals A of 0 e to the kt, notice that A will be 0.60 A sub 0, which equals A sub 0 e to the k times 240. So here's 240, and then the A is where we put 0.6 times A sub 0. Well, notice here if I divide each side by A sub 0, that these both reduce out, and all I'm left with is 0.60 equals e to the k times 240. Well, we know that solving for k here, I would take natural log, so this would end up being natural log of 0.60, which equals 240k, and therefore k is equal to natural log of 0.60 divided by 240. Which is approximately, putting in my calculator, I'll have natural log 0.60 divided by 240. And we can see that's going to be negative 0.0021, and we can round to that 2 to 3. So negative 0.00213. All right, so now what we have is A of t equal to A sub 0 of e to the negative 0.00213 t. And now we can go ahead and begin to answer the very first question, which was A of what is the half-life. Now, recall that the half-life is when the element decays to half of the original amount, meaning that when your element decays to 50% of its original amount. Therefore, A sub A, we want to know t is equal to what when A is equal to 0.5 of the original amount. Let's go ahead and figure this out. We know that A of t is equal to A sub 0 e to the negative 0.00213 t. If I plug in this information, I would get 0.5 A sub 0 on the left equal to A sub 0 e to the negative 0.00213 t. And once again, we'll notice that the A sub zeros reduce out, and we're left with 0.5 equal to e to the negative 0.00213 t. And we can take natural log of each side, so we'll have natural log of 0.5, which is equal to negative 0.00213 t. And therefore, t will be equal to natural log of a half divided by negative 0.00213. And I want to remind you to keep that negative because the natural log of a half is a negative and time can only be positive, so you need that negative. Make sure you don't leave that out. And then we'll go ahead and find an approximated value for t by putting natural log 0.5 over negative 0.00213 in our calculator. So let's go to our calculator, and we'll have once again the natural log, in this case 0.5, divided by negative 0.00213. And we can see from the answer that it's 3025.42. And again, the units on the time were days. So it would take about 325.42 days in order for this element to decay to half of its original amount.